Hey everybody, the purpose of this video is to get you guys some solutions, needed chalk, to the Prisoner Problem Revisited quiz from this week. So the question about this one, the problem is outlined, but the idea is to try to live with as much likelihood as possible. So the first question is to remember what the perfect solution was for 10 white and 10 black marbles. And that ideal solution was to put in one bowl one white marble, and in the other bowl the other 9 whites and the 10 black marbles. So essentially you put one white marble in one bowl or urn, whatever, bag, bowl, and everything else in the other. And then the next question was, what's that maximum chance of living? Now we figured this out as a class together back first week. I think it was the end of the first week of class. Half the time you're going to pick with 100% certainty the left bowl, which means half the time you're going to live automatically. And it only gets better from that. The other half the time, you're going to pick from this bowl, which has a 9 in 19ths percentage of living. So you got a 100% chance of living over here, and a 9 in 19ths chance of living over here. And if you add all that together and round it off to 2 decimals of a percentage, which I said to do, I ended up getting, let me see, 73.68%. So that's the best chance of living you can have. The best chance of living you can have, 73.68%. Cool. Now we started messing with it. The next question was, suppose he uses 100 black and 100 white. Now what I wanted you to see on this quiz was I wanted you to get at the point of, oh, FYI, before we get into this, whenever you see a W on a quiz, show your work, there's an example of work. If I just got this answer, I'd have no idea how you got it. And even if you understood what I was trying to get you to see, this demonstrates to me that you do. So what you need to do now is you have to adjust the new problem. Now the new problem still has an element of the old problem. Still has an element of the old problem in that you have 2 bowls. You have 2 bowls, and you're selecting randomly from those 2 bowls. So let me actually write this better. Instead of writing 1/2 and 1/2, let's put the bowls here in 3. And the chances down here in 4, which is where we're getting at here. There we go. Okay, now, we're still going to pick this bowl half the time and this bowl half the time. Now, clearly, what we want to do is we'd like to make both bowls 100% likely of living, but there's no way that can happen because we have black marbles, and black means die. So, seemingly, the best thing we could possibly do is throw at least 1 white marble in each one. Right now, if we could stop with that, we'd have a 100% chance of living. But the problem is we can't stop with that. We have to mix the black marbles in somewhere. If we start putting the black marbles in both bowls, that means that any one of those bowls is going to have less than a 100% chance if we grab it. So let's use the logic from the first problem. If we leave 1 white marble and only 1 white marble in this bowl, when we grab that bowl, we have a 100% chance of living. But that means if we only put 1 white marble in this bowl, we've got to put the rest over here, which would be 99 white marbles and 199 black marbles. Which, we can compute that really quickly. Let's just change that to 99. Oops, 99 out of 199. That ends up being 74.87%. Now I'm answering 3 and 4 at the same time here. So hopefully you realize it makes no sense to put any more than 1 white marble in this bin, because if you pull, say, another white marble and put it over here, this is still a 100% chance of living, but now this right here is going to go down, which means this is going to go down. So the best chance you have of living is going to be throw 1 white marble on that one, the rest in here. The next question is, suppose the emperor uses, I think it's 1,000 each. 1,000 each. Well, hopefully you're seeing the pattern. The pattern is put 1 white marble, in the one bin, and put the rest in the other. As far as, let's go somewhere else with the board. I'm running out of board, aren't I? Let's leave this and this. I'll put 6 down here. As far as the likelihood, you still have that 1/2 of 1. That hasn't changed. But now you've got 1/2 of the remainder, which is 999 out of 1,999. Am I doing this right? Yeah, there's 2,000 total. So 999 out of 2,000, 1,999, which is going to give us, let me change those numbers real quick. It's going to creep up a little bit more. Beautiful, and that ends up being 74.99. 74.99%. I should be writing this as percentages since I told you guys to. All right. Now, at this point, I stopped asking you by giving you numbers of marbles. And instead, I asked you, suppose the emperor keeps doing this, where he keeps increasing the number of white and black marbles evenly. And I said, what limiting percentage do you appear to get? What we're going to do is we're going to explore this real quickly here on the computer. Let me slide the camera down and zoom it in so you can see it. Please excuse my lack of clever. There we go. There's the percentage right there. That looks backwards in my viewfinder. I hope it is not backwards on the film. Oh, no, it's good. It's just backwards in my viewfinder. So what happens if we use 10,000 white and 10,000 black marbles? Well, that means we're still going to do it the exact same way. We're still going to throw one white marble in one bowl and the rest in the other. But then it ends up being 74.9987, which rounds to 75%, but it's still under 75%. What if he uses 100,000 and 100,000 white and black marbles? Well, then it ends up being 74.99987%. What if he uses, we would just say 100,000. What if we use 1,000,000 white marbles and 1,000,000 black marbles? Then it ends up being 74.9999. Notice with every time we go up an order of magnitude of multiple of 10, we pick up one more 9 here. The next question was, what does it appear, what percentage do these numbers appear to be getting to? And hopefully you see it now. They appear to be getting to 75%. They're close, but they're not equal to 75%. So that next question on the quiz is number 5. What percent does this appear to be approaching? So this is actually number 5. Excuse me, this is actually number 4, isn't it? Yep. These are all continuations of number 4. These guys. 5 is, what percent do they appear to be approaching? Well, it appears to be approaching 75%. Each time we increase the marbles, we pick by a factor of 10, we pick up one more 9, which is actually a move of a factor of 10, if you think about it that way. And then number 6 is, convince me why the actual probability can never meet nor exceed 75. Well, let's just play devil's advocate for a second. Let's suppose it could. Okay, this is called a proof by contradiction. This is called a proof by contradiction. It's actually one of the more fun mathematical tools. So let's suppose that we could equal 75% exactly equal. Not a squiggly equals, but exactly equal. We know the logic. We know the logic. We put one white marble in the one bin, and we put the rest in the other, which is always one less white than black. One less white than black. Okay. That would mean, in order for this to be true, we have to figure out what that question mark has to be. Now we know that 1/2 of 1 is 50%. Plus 1/2 of this question mark has to equal 75%. Well, if we take 50% away from 75%, that leaves 25% behind. 1/2 of that would therefore equal 25%. If half of that chance is 25%, that means the whole chance is 50%. Okay, so now we know the whole entire chance is 50%. Well, that means that you've got a fraction in here. You've got the number of white over the total number of marbles is exactly, not approximately, but exactly 50%. That means that this number has to be exactly half of that number, exactly half. So if this is 8, this has to be 4, and so forth and so on and so forth and so on. Well, there's no way that can actually happen, is there? Now think about why. Think about why. There's no way that can actually happen because of the way the numbers are set up. Because there's always one less white than there are black. So in other words, this total number has to be the number of white plus the number of black. Let's write that a different way. The only way for the number of white divided by the number of white plus the number of black to be the same, to make this equal 50%, means that this and this have to be the same number. Right? If this divided by this is exactly 1/2, that means this is exactly 1/2 of this, which means this and this have to be the same. But they're not the same. By definition, there's always one less white marble. So this can never equal 50%, which means it's a contradiction. Since this can never equal 50%, we can never meet the number in number 5. For the same reason, you can't exceed it. For the same exact reason, you can't exceed it. The only way this could possibly get bigger than 50% is if this were less than this. But we know that's not true either. So there's no way for that to ever equal or be greater than 75%. That's one way to explain it. You can explain it any way you want to. But that's just, I think, the most logical, simple way to explain it. Hope it helped.